All right, so hopefully you can hear me. My voice isn't the best. Um, we're going to use the math talk from lesson 9.1, but the rest of it, I'd probably just put it all in your notes. So just get some loose leaf ready. This is the only part that's in your binder. Otherwise, I just put it all on loose leaf. Why don't you pause the video and take just a couple of minutes to look through these problems and figure out what the variables are. Then hopefully, when you look at the first one for A, you can just see you should know 4 squared is 16. Therefore, A is 2. What do we need to do to 4 to get 2? We need to square root it, right? Well, that means that's 4 to the 1/2 is 2. Therefore, B is 1/2. What do we do to 4 to make it into a fraction? We make it a negative exponent. So C is -1. In this one, what we need to do is just rewrite it using our square root. Remember, we move our denominator to the index and then raise it to the 5th power. The square root of 4 is 2. 2 to the 5th is 32. So D is 32. But what about the last one? Did you get stuck? There is nothing that I can do to 4 to get 56. Did you try and think how you could estimate it? So if you use your card and you think about your powers of 4, 4 to the first is 4, 4 to the second is 16, 4 to the third is 64. So 4 to the E is going to be somewhere in between 4 squared and 4 to the third. So E has to be in between 2 and 3, not equal to. And because it's closer to 56, you might have said, oh, it's closer to 64. Maybe it's like 2.8 or something like that. But we know that it's going to be in between these two numbers somewhere. We just don't know that value. And that kind of leads us into why we need to learn about another function, a new function. And we can even see how this fits on the graph. So we said that A is 2. When A is 2, that's our x value. Y is 16. So if you look at 2, 16 is right there on the graph. When B was 1/2, see how the Y fits what it equals? 1/2, 2. You don't need to put this in your notes. Just kind of notice -1, 1/4. It's about right there. 5 halves. So that's like 2.5, right? So if we go between 2.5 and follow it all the way up, it's going to get to 32. And we can't see where that's at, but it's going to be between 2 and 3. All right, so I want you to start thinking about inverse operations. These are things you actually know how to do. You know that the inverse of add is subtract, and subtract is add. You know the inverse of multiply is divide, and divide is multiply. And we could even add to this, right? If we use powers, we use roots. And roots, we use powers. Those are also inverse. So you're going to learn about a new function this week called logarithms. So a logarithmic function is something new but it's just the inverse of exponential. So one of the things we use inverses for is to undo an operation to solve equations, right? So think about your basic equations, x plus 3 equals 6. How would we undo what's going on to x? Since 3 is being added to x, we subtract 3 from both sides because we want to undo what's being done to x, so we get x by itself. So we know the inverse is subtract 3. When we see multiplication, 2 times x, we know we need to divide because division undoes multiplication. Whatever we do to one side, we have to do to the other. X is 5. We know the inverse is divide by 2. For some reason, this one always gets people. We see that x is being divided by 2, so the inverse of divide is multiply. So I multiply both sides by 2 to undo divide by 2. X equals 12. So a big reason we need logarithms will undo exponential functions. All right, so we're going to start with some basic stuff. And anytime you need to pause the video to take your notes so you can actually hear what I'm saying, hopefully you can hear what I'm saying, do so. So I want you to think about when you first started learning about subtraction, you may have written subtraction equations that go along with addition equations. So 2 plus 3 equals 5 could also be rewritten as 5 minus 3 equals 2. If 7 plus 3 equals 10, then I know that 10 minus 7 equals 3. And just like every addition equation can be written as subtraction, or every multiplication problem can be written as an addition problem, every exponential equation can be written as a logarithm equation and vice versa. So first of all, I think it's important to understand how you read this equation. And if you have a calculator, you can see there's a button on there that you might have been wondering about. That's the logarithm function on your calculator. But we read this, log base 2 of 32 equals 5. What's really important, the base should be subscripted, kind of like the 32 is at the same level as the log. The 2 should be subscripted kind of underneath the log. All right? But this is read the base. Log base 2 of 32 equals 5. So let's look into this a little bit more. If this is the base of the log and logarithms are inverses of exponential, we're going to rewrite it. So whatever the base of the log is, that's going to be the base exponentially. And I kind of just say we kind of go in a circle. We start with the base, 2 raised to the power of 5 equals, and go around 32. And when you write your exponential, you should be able to verify, yes, that is true. 2 to the 5th power does equal 32. And 5 log base 5 of 1 equals 0. Start with the base of the log, 5. Raise it to the 0 equals 1. And we know anything to the 0 power equals 1. So both of these are really the same statement. They're just written. One is written logarithmically. One is written exponentially. So one of the things you're going to have to do on the next checkpoint is write logarithms as exponential and exponential as logarithms. So let's now go backwards. The base of the exponent is 10, so that becomes log base 10, little 10 underneath, of, kind of go around, 0.1 equals -1. Log, take the base exponentially, that turns into the subscript, the base of the log, go around, of 2 equals -1. Now, I want you to think about, why does log base 2 of 32 equal 5? So the key to all of this, where were all of these answers exponentially? The answer's the exponent. All right? So think about what this is saying. Log base 2, what we want to do is figure out 32 is what exponentially? Because 32 equals 2 to the 5th, what we're going to do is replace 32 with the power of 2, 2 to the 5th, and it will equal 5, because just like subtraction cancels out addition, undoes, multiplication and division, they undo each other. Multiply undoes divide. Because logarithms and exponentials are inverses, if the base of the log matches the base exponentially, they cancel each other out, and the answer is the exponent. This is going to seem strange for a while, but we're going to practice. So pause the video and write out these special log values. Let b be a positive real number such that b is not equal to 1. Anytime you take the log of 1, log base b of 1 is 0, because if I look at this exponentially, any base to the 0 power will always equal 1. If you take log of the same base, this exponent is 1. So b raised to the first will always equal b to the first. If these are the same bases, if the base of the log matches the base of the exponent, the answer will always be the exponent, because if I rewrite this, b to the x equals b to the x. All right, so let's look at a couple of examples. I would get out your card and use your card to look for powers. All right, and I'll just tell you now, that's your hint. Match the bases. So if the base is 3, what I want to do is replace 81 with a base of 3. So you keep this one the same, replace 81 with 3. 3 to what power is 81? 3 to the 4th. If you can match the bases, the base of the log cancels the base of the exponent, and the answer is the exponent. All right, the base of the log is 6. And I need to see this step. I can't just see an answer. I need to see, how did you get that answer? So we're going to substitute 36 with 6 to a power. 6 to what power is 36? 6 squared. So the base of the log cancels the base of the exponent, and the answer is 2. All right, so this one's a little tougher because it's a decimal. Well, I'm going to tell you, when you're evaluating logs, the best thing to do with decimals is to rewrite as a fraction. So this is, when you read this, this is 4/100ths, 4 over 100. Well, what is 4 over 100 when you simplify? If I divide both of them by 4, I get 1 over 25. So the first thing we're going to do is change the decimal into a fraction. And then we're going to take this in steps. Because the log of the base is 5, I can change 25 into 5 squared. But see how that 5 squared is in the denominator. So what I need to do is move the 5 squared out of the denominator. And what do you do to move it to the numerator? Make the exponent negative. So once I match the bases, this is base 5, this has to be 5 to a power. The bases cancel, and the answer's the exponent. Oh, too far. All right, last one. These are all a little bit different. For this one, we can think of this a couple of ways. Sometimes you end up changing both the bases. So like 9, I can think of as 3 squared. That's all in the base. And I'm going to leave 3 as 3 to the first. So it's just the bases that cancel. So what I do is cancel out the base 3. Now look, watch the board as I'm doing this. The answer to this, the 3's are gone. I'm left with 1 over 2. It turns to a fraction, 1/2. All right. I'm going to do the same thing on the next one. Hopefully I'm back tomorrow, and then I can work through any kinks of this. All right, 1/2. Remember, 1/2. I can move this up and make that 2 to the negative 1. So my base, I'm going to make 2 to the negative 1. The 8, I'm going to make 2 to the third. So the base 2's cancel. The log base 2 cancels out the base of the exponent 2. And I'm left with 3 over negative 1. But 3 divided by negative 1 is just negative 3. Now the next ones, it doesn't matter if the log comes first or the exponent comes first, right? So here, see how this is 5 raised to the power of log base 5 of 4. So this time it's the exponent that comes first, but it's base 5. This is log base 5. The base 5's cancel, and it's just 4. In letter G, the base exponentially is 2. The base of the log is 2. The bases cancel, and it's just 4. So if you need to rewatch the video, the big thing's going to be just taking the notes from the video, and then tomorrow we'll have some practice.